What is project-based learning and why would we do it? I'm going to talk through the elements of a PBL project and show you the structure of a general project, and then how we would apply PBL to a science depth study. Firstly, what's the advantage? The idea is that a PBL project gives students a real-world context for the things that they learn. It forces them to seek knowledge out in order to complete the project, but is structured enough and contains enough direct teaching that it's not just 15 hours of self-directed learning. It's designed to replicate the sort of environment they would enter in the workplace, where they're faced with open-ended questions and have to plan and manage a group working to create a product. The project begins with an open-ended question, sometimes called a driving question, and this is generally presented at some kind of entry event. The students then have to use their questioning and problem-solving skills to define the question, identify what they need to know, research and work to create and refine a final product. This may be followed by a reflection or debrief. This diagram shows the typical structure of a PBL project. There are 3 phases: the learning, application, and creation phases. Each phase has an assessment, but not all the assessments need to count towards the final mark. In the learning phase, the students are given the driving question, and this is where the most direct learning occurs, as the teacher is passing on the skills and content needed to finish the project. The blue buttons at the top represent the teacher's knowledge. You can see most of it being passed on in phase 1, but there's still teaching occurring in later phases, though it is more targeted and may be given just to individual groups in response to a need. For science projects, the learning phase is also where experiments are done as a class as part of their gathering of information. Phase 1 is generally done and assessed individually with something like a topic test. Stages 2 and 3 are generally done in groups, where students plan and then create their product. The product at the bottom there could be a PowerPoint, talk or video, or a written report. The Phase 2 assessment could be for scripts, drafts, or reflections on their learning. There's opportunity here for teacher or peer feedback, shown at the right as critical friends. The product is assessed at the end of Stage 3. The next slide shows where a university could add to a project. The entry event could be an excursion for schools close enough to the university. We also offer online videos of current research projects. At the university or at school, the driving question would be introduced, something based on a syllabus topic. Our plan for the UNSW depth studies is that all students do the same experiments and cover the same content in Phase 1. Our intention is that each depth study should include several hours of time spent conducting experiments, analysing and presenting data, and drawing conclusions. All of the students of a school would do this in common so that it can be assessed later with a prac test. We can offer schools extra sets of data from the excursion experiments if needed. We will suggest a range of research questions based on each excursion and on research being done at UNSW. Schools could then decide if they want students to all have the same question or if they will offer options for groups to select from. The rest of the project would take place at school. Students would apply their current knowledge and work out what else they need to know. We have online resources to help students with their research. Then, students could share their research and try to construct a plausible solution to their problem. This could often involve evaluating the ideas of different members of the group. UNSW could assist at this stage with consultation via Skype with postgrad students to help each group with feedback. The final step would be where the groups present their reports. It would also be possible to add a reflection task about their learning or how their particular research topic ties in with the preliminary experiments and teaching. That brings us to assessment and how it could be structured. I've shown a couple of options for the parts of the assessment task, but schools may prefer to have only one or two parts counting towards a final mark. We have weighted the prac test heavily, as you can see, as this is the part all the students have done in common, and it is done individually, so there can't be complaints about disadvantage from a difficult project or group. It would also free students to attempt challenging projects without fearing a low mark. The final report could be assessed on quality of research and communication skills as well as on content. You can find among the modules of this open learning course a possible marking rubric for a research report and also for an experimental-based report. The third task could assess Phase 2 or be added to Phase 3 as a reflection on the project. This task could focus on bringing together all of their learning from the entire project. A project outline, if you do it that way, could include a requirement that they explain how the experiments from Phase 1 tie in with their particular research topic, and summarise the physics knowledge that they have acquired in order to create their product. A reflection task at the end could have similar requirements. An example of a Year 11 physics depth study is sound waves. The driving question for this project would be something like, how does knowledge of sound waves help in acoustic design? UNSW will host excursions where students can do experiments on standing waves and measuring the speed of sound. We include instructions for other related experiments that can be done at school. For example, testing the relationship between sound intensity and distance. Groups can choose a particular research topic like, what material has the best soundproofing qualities, or what materials reflect sound the best. They can then identify things they need to know, like how do we measure sound levels, and what is a decibel. Students have to analyse the problem as a team. They research and then plan and carry out an experiment to test different materials. Finally, they write a report describing the process and summarising their results. Teachers can decide what intermediate steps they would like to include, like drafts, peer reviews, and reflections on student learning, and whether they would like expert consultation with a postgrad student at university. Evaluation of PBL shows that it works best when students have the opportunity to produce a first draft and then get feedback and refine their product before the final presentation. Ultimately, it's up to you whether you run the depth study as PBL or not. But even if your students haven't done that sort of project before, they could benefit from the chance to do some learning in context and to manage their own project that is based on authentic projects that scientists are working on at universities and in industry.